Hi, Year 11s. We'll continue in Chapter 13 with some of the application of trigonometry and combined with geometry. In 13G, we're looking at problems in 3 dimensions. So have a look at this example, the drawing with the drawing and the dimensions, and look at determining A, B, C, D. Now, before you pause the video and attempt those questions, always do a diagram that is extracted from the three-dimensional drawing. So if you need to calculate some dimensions that require a specific shape, which is in this case will be triangles, draw your triangles, label the vertices and all the dimensions that you know. Either it will be the edges or the angles. All right, and we'll be back in a minute. All right, so let's continue. To find the distance dB, which is in a horizontal plane, draw your triangle. So that's our triangle DAB, and we know the two sides. We can determine the hypotenuse using the Pythagorean theorem. This value will need to be as accurate as possible, even if you round it off to decimal places. For part B, use its exact form to get an accurate value for part B. In part B, we have a vertical plane which is cutting through H, D, and B. Here's our triangle. You have the dimensions. You need to determine the angle. The hypotenuse. The angle will come later. So with the hypotenuse, again, we use Pythagoras theorem again. Here is the answer you will use at this decimal place. Again, keep the exact value if it's required later on. Alright, and yes, we do need the exact value from before, which is BD. We have our triangle, the dimensions, the angle is to be determined. With the next part, we have a different triangle, different dimension, and we need to use that angle. So depending on the dimensions that you have to determine the angle, you use one of the trigonometric ratio. Here will be the tangent, here will be the cos. You do the inverse to determine the angle. Or do make sure your calculator is set in the correct units. Alright, second example, very similar. You will have a pyramid. You will know the dimension of the base. So as it mentioned, it's a square base. So CD, which is 6 centimeters, will be the same as BC and all the other edges of the square base. And the edges that start from the top of the pyramid to the corner of the squares are equal to 10 centimeters, and there's 4 of them all around. Okay, so pause the video, do a diagram of the triangles that will include those dimensions, and label the sides that you know. Alright, so let's continue. For DB, you draw the base. You need to find the diagonal of that square. You use Pythagoras. That will be 6 root 2 in centimeters. Then for BE, which is half, you just half it. That's 3 root 2. Now we go vertically. We needed BE that we had from before. We know the length VB, we need to do VE, so we use a rearranged formula of the Pythagoras theorem, and we get the value here, an exact value, which is root of 82 centimeters. And then from that, to determine that angle theta, what we can use is, as we know, the opposite side, we use the sine and we inverse the sine and we get that amount. Just get an idea of the magnitude of the angle. I know even if the drawing is not to scale, that angle has to be more than 45 degrees. It has to be positive and less than 90 degrees. Alright, last example. Examples would tend to be lead to questions that will be more related to a SAC or exams, so it's a kind of a worded question. Have a read first, pause the video to determine what you need to do, and again for part A and B, draw the diagram of the triangles that are involved. Okay, so you have your diagram, it's labeled, you need to find the highest of the mast, so we're going to isolate the triangle CAH. We use Pythagoras to find the hypotenuse. And for part B, we want to find the angle of elevation from the top of the mast, which is H, to B. So we draw a different triangle, which is, hang on, wait. So we have the height, let me go back, I jumped the gun a bit too quick. So we need to we determine AC first from the base, the rectangular base. So AC is 75. Then in the vertical plane we have CAH, which is the triangle with the height of the mast. We from the previous part we have 75 meters. We have our angle. We use the tangent formula to get the height of the mast. Yeah, I guess you could use the decimal form. I would recommend to use that exact form, 75 tangent of 12 degrees for part B. And then for part B, we have our triangle BAH. We need to find an angle. We have the bottom part, which is 45 meters, and from before the height is 75 tangent of 12 degrees. We use the tangent expression, so the angle theta is approximate down here. And to answer the question, you write a sentence: the angle of elevation of the top of the mast H from B is 19.71 degrees, correct to 2 decimal places. Yep. Alright, so that's it for 13G. See you later.